Hello everyone. In this lesson we are going to identify one solution, no solution, or infinite number of solutions for equations when you use various mathematical practices, inverse operations. But for this one right here, we're just going to solve the equation right now. Remember, an equation has an equal sign, and when you see parentheses, you just go straight to distributive property. Bring everything else down after the distributive property. When you multiply a half by any number, you are halving that number. So a half times 6x is 3x, and a half times -4 is -2. Now you see the left side of your equation. That has three terms, and that means there are like terms to combine. So you have 3x plus 4x, and we're looking at the term right here and right here. So that is 7x. When we go and put that down, bring the -6 down, the equal sign down, and the 3x minus 2. Now, your job is to solve this by getting the smaller coefficient, smaller x, over to the larger x. And just like that, we are going to cancel out the 3x, and we're going to go 4x minus 6 equals -2. And I'm going to rewrite that right here. 4x minus 6 equals -2. When we go ahead and we get the x, we try to get the x alone, we're using inverse operations to get the 6 over to the -2. And at this point, we have 4x equals 4. We divide by 4, and x equals 1. So that is x equals 1, and we're going to go and solve for this missing variable. How many solutions does this equation have? Let's solve it first, and then we could see exactly what's going on. So I see distributive property that I have to do, but I also have to combine like terms, the -8 and the -1, right here and here. So let's go ahead and do that for x. -8 minus 1 is -9. Now that says two terms, and then we're going to do distributive property going from left to right. You have 5 times 2x. That's 10x. And then we have 5 times -3 is -15. Be careful with that. So we subtract 4x on both sides, getting the smaller x over to the larger x. This cancels. You get -9 equals 6x minus 15. Now I could already tell you that this has one solution. And it has one solution because it has only one x. You see there's only one x. We're going to solve for a number. So we have -9 plus 15 is 6 equals 6x. And the last thing that I'm going to show you is divide by 6 on both sides. And then x equals 1. So 1 equals x. And I just wanted to move this back down to here, just showing you that the x is really on the right side, and the equal sign comes straight down, and the 1 comes right down below the 6 divided by 6. This does have one solution. The solution is 1. All right, so how many values of x make the following equation true, and how can you be sure? So I'm going to move this over right now, and I'm going to solve it. Minus 3x, minus 3x, and we are going to cancel the 3x's, and we're going to bring 2x plus 2 down, equals 8. Now, I told you before, if there was, like, if you paid attention, or if you understood what I said, if there's one x, that means you're going to have one solution. So this comes out to be 2x equals 6, and then you're going to divide by 2 on both sides, and you're going to get x equals 3. That is one solution. And I just wrote down x equals 3 is one solution. You can tell the equation has one solution right off the bat without solving it, because the x's are different. Like the coefficients in front of the x's, the variables are different. If they are different, that means when you go ahead and subtract and get them together on one side, you're going to have one solution. Just like right here, when you're taking a look, minus 3x, that is 2x plus 2 equals 8, and that is one solution. So in the 6th and 7th grade, we learned that every equation only has one solution. The solution is the number that makes both sides of the equation balanced, which is equal. Let's explore the equation below, and we are going to go and see if we can solve this. So at this point, I'm going to go like this. This is 8x, 2 times 4x, and 2 times 1 is 2. Now, just look. It's the same expression on both sides. So you can tell right now that you have infinitely many solutions, and what that means is that any number will work. If you substitute it into the left, that same number will work on the right. So it's infinitely many solutions. You could tell right away you have the same expression on both sides. 8x plus 2 is always going to be equal to 8x plus 2. And when can you stop and determine the number of solutions? Well, you could stop when you have the same expression on both sides. If you wanted to go further, if you did, I'm going to put this down, 8x plus 2 equals 8x plus 2. You just go ahead and solve the equation just like you normally would any equation, getting the x's together. Once you get the x's together, look what happens. This cancels, and then you have 2 equals 2. Same expression on both sides. I don't know why I'm putting a check mark there. This is infinitely many solutions. And that is it. All right, let's go on. Jason says that a linear equation always has just one solution. Amy says that some linear equations have more than one solution. Who's right? Solve the equation to see if it could have more than one solution. So we have combined like terms. We have 2x plus 1x. That is 3x plus 1. Equals, and let's do distributive property here. We have 3x minus 6 plus 7. Well, we're going to combine like terms there, and then we're going to have 3x plus 1 equals 3x plus 1. Negative 6 plus 7 is 1. Since you have the same expressions on both sides, it's infinitely many solutions. They are the same. So I'm going to highlight this one and this one. Same expressions. And when you have the same expressions, you will have infinitely many solutions. And that's it. Is there another value of x that satisfies the equation? Yes. All values of x satisfy the equation. And that's it. So we're going to solve each equation and determine which one has no solution, but we're just going to roll through and see what type of solutions they have. But just remember, you have to get the x's together first. It's the first thing that you do, is get those x's together. So this is x equals 1. This is one solution. This one right here, you have the same x's, but different other numbers, the constants. So we're going to get the x's together first, and we're going to cancel both of those sides out. 4 does not equal 1. This has no solution. Now think about it. 3x plus 4 can never be equal to 3x plus 1. It's just not going to be equal ever. So that's what it means when there is no solution. So we have 12x minus 8 equals 12x minus 8. That is the same expression on both sides. And we are talking about infinitely many solutions. And that is because, and you recognize it because you have the same expression on both sides. And those are the three types of equations that we're going to be dealing with here. What value for the constant p? So this value, they want a value for this, will result in no solution. So just remember what no solution represents. No solution, and if you put it here, same x, different constant. So you have to have the same x. So if you're talking about this right here, 6x, what times 2 will equal 6? Negative 3? That's negative 6. No good. 0? Not at all. 1.5 times 2? No. 3. So let's go ahead and put 3 times 2x plus 5 equals 6x plus 9. So this is 6x. 3 times 2x is 6x plus 15 equals 6x plus 9. That's no solution. All right. And there you go. So we're going to have Mickey and his friends, Mickey, Donald, and Minnie. We're each given an equation to solve. How much does each equation have? As far as the solutions go, we're going to go ahead and do this for Mickey right now. So this is 2x plus 20 minus 17 equals 5 plus 2x minus 2. And we're going to combine like terms. You see each side has 3 terms. So we're going to just go and do 20 minus 17, which is 3. So 2x plus 3 equals, and then we're going to put this 2x first, and we're going to do 5 minus 2 is plus 3. Infinitely many solutions. And we're going to go right over the mini, and we'll combine like terms on this side, this left side first. This is 5x minus 3x. So we're going to put that down as 2x and then bring down the plus 3 equals. we're going to do distributive property and combine like terms, which is 2x plus 6 minus 5. So we have 2x plus 3 equals 2x plus 1, 6 minus 5. Now, we do not have the same expression. We have the same x's and different constants. So with that, if you don't recognize this as no solution, we could just go ahead and cancel these out. This is 3 does not equal 1, and that is no solution. All right. And the last one is Donald. So we're going to pick green for Donald, and we're just going to go and distribute because that is what we have to do. So that is 6 plus 9 equals 5 plus x minus 1. Now 2x minus 6 plus 9, negative 6 plus 9 is 3. A positive 3. And then I'm going to have an x. I'm going to put that x first. 5 minus 1 is 4. Now, I could already tell this has one solution. There's different x's. Different x values means one solution. So we're going to solve this. This cancels. You have x plus 3 equals 4, minus 3, and x equals 1. And this is one solution. And those are the different equations that we are working on in this lesson. All right, so summary, use prior investigation to verbalize how you know when an equation has one solution, no solutions, or infinitely many solutions. So fill this out based on what we've done to this point in the lesson. Okay, so when an equation has one solution, you could tell the x values are different, or there is only one x value in the equation. You have 3x minus 10 equals 40. You'll have one solution. 5x plus 40 equals 6x minus 20. Different x's on both sides. That's it, has one solution. I can tell an equation has no solution when the x values are exactly the same. The coefficients of those x's are exactly the same. You see you have 3x and 3x, and the constants, the 40 and the negative 10, are different. That is no solution. I can tell when an equation has infinitely many solutions when it's the same exact expression on both sides, like 5x plus 8 equals 5x plus 8. All right, so right now we're just going to go ahead and just remember, you have to get the x's together first. So on this side they cancel, and on this side it's 12x plus 20 equals negative 20. So right now we have one solution. Now, sometimes they'll have you solve for that one solution. It is good practice. We could cross out no solution. Wow. We could cross out this. We could cross out this. So we're just going to go up a little bit, and we're going to minus 20 on both sides. This cancels. You have 12x equals negative 40. You divide by 12 on both sides. And it is not 0. We know that it is a. So x equals negative 10 over 3. And you can do this. I'll just show you a little bit of a trick. If you have negative 40 over 12, I'm going to go alpha x, and if you want to reduce a fraction, you press enter and look, negative 10 over 3. It reduces it for you. It's a really nice feature of this calculator. And just remember, you can put a fraction in, press enter, it reduces it. All right, so here we go. Solve this equation, win the puppy. Negative 10x, negative 15 equals, and half, remember, when you multiply by a half, it is half of the number. So I'm not even using my calculator. Half of negative 20 and half of negative 30 is negative 15. So we have the same exact expression on both sides. So if you have the same exact expression on both sides, I'm going to put that same expression. And that, you know what that means? It means any number that you put in the left will work if you put it in the right. And that's infinitely many solutions. And that is it. Extra practice, try this question. Again, we would have negative, Kermit looks at the equation. Just rewrite every equation. All right? Don't try to, skate by and not rewrite it. You have plus 6x plus 6x. This cancels. This does not. Negative 30 equals, just remember, you're adding 6x on both sides, so that's 12x minus 30. This is one solution. And there it is right there. You could read that. If you wanted to, you could keep on going, but you really don't have to. This cancels. You have 12x equals negative 27, but it really does not matter what the solution is. They don't even tell you to solve for the solution. It's just that it is one x value. You will have only one solution there. So this says to determine the number of solutions, we have 8j minus 32. This is 8j minus 32. And that is infinitely many solutions. Going on, we're going to just make sure that we could fill in the blank that will have the type of solution shown. Just remember, no solution, same x, different constants, different other. So this one, they have the same x, but you could put anything but 5 in there. So I could put 4. Infinitely many solutions, same expression. So this is 1/3 x plus 5, 1/3 x plus 5. It only could be one number. One solution, that means we have different values of x. It has to be. So this could be, say, 5x. That really looks dark. That looks dark too. Now, all right, there you go. And that is it. All right, try these equations. Identify if they have one solution, no solutions, or many solutions. If they have one solution, I'm going to try to solve it, but let's go ahead. We have minus 15x and minus 15x. This is tricky. So we're going to go and cancel out and cancel out. You have 10 does not equal 0. No solution. And it makes sense, right? No solution because 15x plus 10 can never be equal to just 15x. So think about that. All right, so we have 3 times 6 and 3 times negative 4. 18 minus 12x equals, and we're going to go negative 12x. And this is positive 18. Yes, it's the same expression. Infinitely many solutions. I mean, really. Move this over. Okay. And the last one on the bottom. I'm going to do distributive property. It looks long. 6x plus 10 equals, we're going to go distributive property, 10x. 5 times negative 4 is negative 20 minus 4x. We're going to combine like terms on the right side before doing anything. 10x minus 4x is 6x minus 20. Now this already has the same x. Same x. Let me put this over here. Different constants. Different other. So right here, you should be able to tell that's no solution. If you wanted to go further, you would minus the 6x on both sides. And these would cancel. And you would get 10 does not equal negative 20. And either way, it's no solution. All right, here's the exit slip. We're going to solve each one, but I'm going to tell you right now, I could tell what this is. It's the same x. Different constants. So that means there's no solution. But if you really wanted to, you'd put negative 8x, negative 8x. This cancels, and you get 10 does not equal negative 20. And there is no solution. Now this one I have to do distributive property first to see what's going on. This is 3x plus 6 equals 3x plus 6. Same expression on both sides. Infinitely many solutions. And there it is. So we know that this has the different x's. And that means one solution. So I'm going to go ahead and solve it, because I should be able to solve any equation. You get the smaller x over to the larger x. You add 20 to start to isolate the variable using inverse operations all the way. This is 30 equals 2x. And you have one solution, because that solution is 15. Oh, look. One solution, infinitely many, and none. All right, and that is the exit slip, and that is the lesson. All right, so remember, there's a way to tell if an equation has one solution. That is to just have different x values. The coefficients before the x's, those are different. That means you have different x values, and you will have one solution. When you have the same expression on both sides, that means you have infinitely many solutions. And when you have the same x value, same coefficients, and different constants, that means you have no solution. All right, and that's it. That's the lesson. As always, thank you for watching, and I'll see you next time. Bye, everybody.